Hello everyone, and thank you for your interest in our paper. My name is David, and today I'm excited to talk about our work on learning personal style from a few examples. This work was advised by my advisor, Nick Martelaro, and supported by a gift from Accenture Technology Labs. A designer needs to understand the client's personal style. For example, some clients may prefer playful or vibrant designs, while others may prefer more hardcore, heavy metal designs. Designers often gain a sense of this personal style based on a few examples from the client. However, especially for junior designers, recognizing a common pattern among many intertwining variables such as color, texture, and layout, and synthesizing them into a composite style preference can be challenging. In this paper, we ask, can we learn a computational model of personal style from only a few examples? We frame our task of modeling the client's personal style from a few examples as a metric learning problem. In other words, given an arbitrary test design we want to evaluate, our objective is to determine its similarity with a set of representative examples selected by the client. This allows to then classify the test design between two classes, client likes or client dislikes. Our resulting computational model predicts a match score, which is how well the test design matches the client's liking. In this presentation, I'll briefly go over our three main contributions. We first distill a set of principles for computationally learning personal style. We then manifest the principles in PseudoClient, a deep metric learning framework for personal graphic design style. Our experimental results show that PseudoClient outperforms several alternative methods and can be also adjusted for different designer needs. Finally, we discuss how PseudoClient can be used as a building block for multiple practical design applications. We ground the design of PseudoClient in four central principles: synthesized from prior work and design, recommender systems, and cognitive psychology. Learn by example. Considering that design vocabulary, such as playful or elegant, is inherently subjective and highly dependent and interpreted based on the individual's knowledge and experiences, we do not ask the clients to indicate their preferences through such vocabulary, nor do we attempt to fit their preferences into such vocabulary. Inspired by the mood board technique, we simply ask the client to supply us with visual examples and learn to judge the client's personal style based on them. Learn by a handful. Since our task is to learn personal style, our examples come directly from the client of interest. However, asking the client to select massive amounts of examples is tedious. Therefore, rather than being data hungry, PseudoClient should be capable of working with only a handful of examples. Learn by juxtaposition. Prior work and recommender systems suggest that it is easier for clients to select positive and negative samples rather than to judge likability on a spectrum. Therefore, we simply ask the client to provide us with some examples they like and some examples they dislike. Learn by multiple comparisons. Studies in the learning sciences and cognitive psychology have observed that through repeatedly doing pairwise comparisons, one can quickly learn a common underlying structure of a pool of examples. We build on this insight in PseudoClient's design. Based on the principles, we designed PseudoClient, our computational model for learning personal style. PseudoClient takes in a test design and outputs a final match score between 0 and 1, which estimates how well the test design aligns with the client's personal style. PseudoClient consists of 3 levels of components. The comparison framework, which contains the Juxtaposition Network, which further contains the Embedding Network. I will now briefly summarize each of the components. For further details, please read our paper or visit our project page linked at the end of the talk. The comparison framework takes in a test graphic design we want to evaluate and a small pool of graphic designs, examples the client likes. We then perform pairwise comparisons between each test design and each reference design in the pool to compute their respective match scores. Our final match score is the median of all the pairwise match scores. A high final match score implies that the test design matches the client's personal style and vice versa. Individual match scores are computed by the Juxtaposition Network, which takes in a test design and a reference design and outputs a match score based on the design's distances in a learned embedding space. The design's learned embedding space is computed by the Embedding Network, which takes in the design and outputs its feature embedding. Again, for further details, please read our paper or visit our project page linked at the end of the talk. We performed several experiments to evaluate PseudoClient's performance. We first trained 5 personalized models for 5 people. Each personalized model was trained with only 5 positive and 5 negative design examples. We compared PseudoClient against 2 common baselines, color histogram distance and a standard convolutional neural network. And we see that PseudoClient outperforms them. PseudoClient's performance also improves as we increase the number of design examples available for referencing. By giving different ratios of like and dislike examples, designers can focus on optimizing true positive accuracies or true negative accuracies. For example, a designer can focus on optimizing true negative accuracies to really avoid producing a design that the client dislikes. Given 5 examples from the client, we demonstrate searching from a database of graphic designs from Dribbble.com for the top 10 designs with the highest match scores. Here is a search retrained with another 5 examples. To wrap up, we suggest potential applications of PseudoClient for augmenting designers. A natural application of PseudoClient is an example-based, style-based search engine. Unlike existing tools built into many design sharing websites, a search engine built on top of PseudoClient does not require the designs to be manually tagged with keywords. PseudoClient can also provide rapid, automatic design feedback to the designer for evaluating how well the designer's design draft aligns with the client's personal style. Finally, PseudoClient can also be used as a key component in generative design methods, where PseudoClient can guide the rapid exploration of multiple design alternatives. In summary, our paper explores how we can computationally learn personal style based on only a few examples. We offer a set of principles for computationally learning personal style. Based on the principles, we designed PseudoClient, a deep metric learning framework for learning personal graphic design style. PseudoClient can be used as a building block to support the development of future design applications. To find out more, I invite you to read our paper or visit our project page. Thank you for your attention, and please reach out with any questions.